Alright guys, so today we're going to be talking about epoxide hydrolysis. And essentially what this is when you have an epoxide in which you have two carbons bonded to an oxygen in this formation, you can react it with hydronium ion, and as a result you can form a diol, or a carbon-carbon bond that has two alcohols at either end. So here is the mechanism as follows. So first, let's draw our epoxide. So you got this structure right here, and then we can draw in our hydronium ion, which is an oxygen bonded to three hydrogens. And it has a positive charge because there's only one lone pair. So essentially what happens here is that this oxygen, which has two lone pairs, is going to grab a hydrogen and move those electrons onto the oxygen with our hydronium ion. So now what we get is a molecule that looks like this. This oxygen is bonded to one hydrogen and therefore has one lone pair, so it's a positive charge. And then we can use our newly formed water molecule to attack our epoxide. And the way we do this is our electrons, one of our lone pairs, is going to attack a carbon. It's going to break that bond, moving those electrons onto our epoxide oxygen. So now what we get is our alcohol, our first alcohol formed here, and our water, which is attached here, which is anti. So now I'm going to just draw this molecule down here again. What's going to happen is we have our alcohol here once again, and we will bring in a water molecule to depronate our hydrogen right here to form the second alcohol. And the reason why this is possible is because we need to remember that hydronium ion is a derivative of water. So in a solution of hydronium ions, water is also present. So what happens here is that a lone pair will grab a hydrogen and move those electrons onto an oxygen. And what we get is our two alcohols that are anti to each other, which is the correct stereochemistry for the end product. In addition, we reform our hydronium ions, so in a scenario where we have more epoxides to hydrolysize, we can do that with the same reagent that we already did it with. So this is the complete reaction and mechanism for epoxide hydrolysis. Have fun with it. I hope this helps, and I'll see you guys in the next video.